Okay, so 5.3, or actually this is actually 5.5. So 5.5, this is where we were solving polynomials, okay? Now in 5.4, we were able to solve them, because remember we're able to tell the zeros. When we're solving, we're just telling where the zeros are. And in 5.4, we were able to do that when we graphed them. We could see where the zeros were. We just looked for where it crossed the x-axis. Now for 5.5, we still want to solve them. Now we're using factoring. So the first thing we did with 5.5 was learn how to factor difference, sum, and difference of perfect cubes. So let's talk about that. Sum and difference of perfect cubes. Okay, now, when we're talking about sum and difference of perfect cubes, what we're saying is that we have something that's a perfect cube, where either we're adding and they're perfect cubes, or we're subtracting and they're perfect cubes. Okay, a perfect cube just means that I can take a number, let's say 2, and I can multiply it 3 times. So like 2 times 2 times 2 gives me 8. So 8 would be a perfect cube. Okay, and when we do sum and difference of perfect cubes, when we factor these are a little bit different than what we're used to. When we factor these, we just need to remember a formula. So the formula for the sum is going to be a plus b, and then we have a to the second minus a times b plus b to the second. Okay, now the formula for the difference, meaning we have a subtraction symbol, is almost identical. The only difference is going to be the sign. So now it's going to be a minus b, a to the second plus ab plus b to the second. Okay, now let's do an example of this. Okay, let's do an example. Let's say we had the problem c to the third minus 125 a to the third. Okay, now our first question whenever we factor is, do we have a greatest common factor? So does 8 and 125, do they share something that we can divide both of them by? Well, the answer is no, so I don't have a greatest common factor between 8 and 25. Then I look at the variables, where these are two separate variables, one's c and one is a, so no, I don't have a common variable. So we can jump straight into difference of perfect cubes. Now, I know these are perfect cubes because 2 times 2 times 2 gives me 8. Okay, so the cube root of 8 would be 2. And now c to the third, if I cube root that, okay, that's just going to give me c. So what this is saying is we have a to the third minus b to the third. Okay, well, my formula for the minus one is the second one. And if you look at the formula, we don't want a to the third and b to the third. We just want a and we just want b. So to find a, you're going to take the cube root of 8c to the third. And to find b, just b, we're going to take the cube root of 125 a to the third. So we just said that 2 times 2 times 2 gives me 8. So the cube root of 8 is 2. And c to the third, all that's going to happen is the exponents are going to cancel. So it just leaves me with 2c as a. Then for b, we're looking for a number that I multiply 3 times. That gives me 125. Well, 5 times 5 times 5 gives me 125. So my b is 5. And a to the third, that's gonna cancel with the cube root, so I'm just left with a. So now I have my a and my b. So I can plug them straight into my formula. My formula says a minus b. Then it says a squared, so it's going to be 4c to the second, and that's because 2 squared is 4. And then my formula says plus a times b, well, 2 times 5 is 10, and a times c. And then my last one would be b squared. Well, 5 squared is 25, and a squared is just a squared, okay? And that would be our final answer. So that is how you find the factor of ac to the third minus 125a to the third. Again, we know that we had to use the difference of perfect cubes because 8 is a perfect cube, 125 is a perfect cube, and we only had 2 terms. This only applies if we have 2 terms. Okay, the next type of factoring we learned was grouping. So I'm going to go ahead and write that down. So with grouping, you need to have at least 4 or more terms. Okay, and we're going to do exactly that. We're going to group. So let's say I give you 3x plus 2xy plus, let's say, az plus 3bx plus 2y plus okay, now I'm looking at these terms and there's 6 of them, so I'm going to group 3 and 3. Now before I group though, I want to make sure they all have something in common. Okay, and actually I forgot to write a variable here. This should be 3a. Okay, so this should have an a right there. Okay, so before I continue, and this should be an a right here as well. Okay, so before I continue, I want to see, do they all have A's? Well, the first 3, yes, they all have A's, so that's good. And the last 3, they all have B's, so that's good. So I'm going to group them. If that wasn't the case, I could rearrange the variables so that they all had something in common. So when I'm looking at this first group, I'm going to ignore completely the second group. So I'm just going to look at the first one. And I'm asking myself, do they all have something in common? Well, they all have an A in common. Okay, so I'm going to go ahead and take out an A. So now my problem is going to be 3x plus 2y plus z. So I'm done with the first one because I found the greatest common factor. Now I'm going to look at the second one. Well, the second one, they all have a b in common. So that's the greatest common factor. So it's going to be b, and I'm left with 3x plus 2y plus z. Okay, and really we're almost done. The reason we're almost done is because our groupings were exactly the same. That's what gives me the clue that I did this correctly, is that my groups are the same. And my final answer would be a plus b. That's what's in front of my groups. And then I just need to write one of the groups, 3x plus 2y plus z. Okay, and that would be your final answer. So with grouping, you group them in groups, and then you look for the greatest common factor in each of the groups. Okay, and that is it for 5.5. That was the first part we did where we solved, or actually we haven't solved yet, we factored by grouping and factored difference in sums of cubes.